Alright, we already kind of talked about consistent, independent, consistent, dependent, and inconsistent. So what I want you to do is I want you to fill in this box, classifying systems of equations. See if you can fill that in for next class period. You should be able to fill those in. If you get stuck, you can either go back through example 1 or you could go check on in your book. I know it's amazing. You can look in your book and find all kinds of interesting stuff. So let's move on to the next method. Well, whenever we find the solution to a system of equations, if you have a couple numbers, you always want to write these as ordered pairs. So you want to write ordered pairs here. So if these are ordered pairs, then when you fill the rest of this in here, we're going to use the substitution method here first. And when we use the substitution method, one equation is solved for a variable in terms of the other. So if you have you have two equations. One of them you're either going to solve for x in terms of y, or solve for y in terms of x. So it's kind of like when you solve the equations for graphing, you solve for y. That's y in terms of x. Then what you do is this expression is substituted. For the variable in the other equation. Hence the name substitution. I know we're getting a little crazy here, but let's see how we use substitution. So if you notice here on example 3, it says use substitution to solve. So you have actually the first example is solve for y, and the second one, or second equation, is solve for y also. So what we're going to do is this x plus 3 is actually going to go in for this y over here. So when you write your two equations, what we've done is we've solved one of the equations for y and we plug it into the second equation. So you're going to get x plus 3 equals to 2x minus 4. And what you've done is you have eliminated your y value. So you have one equation and one unknown. So if we solve this equation, let's go ahead and just subtract x to both sides. So in this case, we're going to be solving for x. Ooh, that's a nice straight line. But we undo that one. So if you solve for x, you get 3 is equal to 2x. Sorry, that's a 1x minus 4. And then you need to move the 4 to the other side. So we're going to add 4. Add 4. And we end up canceling out the 4s, so x equals 7. So that's half your answer, because your final answer should look like this. So if we have our 7 for our x, then we need to solve for y. Well, the nice thing is you can solve for y by plugging this 7 right here in for either equation. It can either go into your bottom equation, where you already have to solve for y, or you can plug it into the top equation. It's going to work for both. So I'm just going to plug it in the top. So you plug y equals 7 plus 3, and you get 10. So your answer should be 7, comma 10. And that's by using substitution. Now, when we do a problem like B, notice this has two equations, but neither one of them solve for x or for y. So the best thing to do is not necessarily solve for y, because if you solve for y, this top equation, you get 4y equals negative x plus 26. And if you divide by 4, then you're going to be substituting in a negative 1/4 x plus a 13 over 2. Well, I kind of like fractions. I know you guys really just dislike them a lot. I really don't want to plug in, substitute a fraction in for y of this next equation. So it wouldn't make a lot of sense to solve for y. So the equation you want to solve for, or you want to solve for the other variable then. So I'm going to erase all this. Because what we can do is, or you always want to solve for the variable with a coefficient of 1. of 1 or negative 1. So either one. Solve for 1 or negative 1. So if you want, you can choose the first equation or the second one. If we solve the first equation, we can just solve that for x instead. So if we have x plus 4y equals 26, if you subtract 4y to both sides, then you get x is equal to negative 4y plus 26. And this negative 4y plus 26, that is what's going to be plugged into, substituted I should say. It's a little better than saying plugged. That's going to go in for x of your second equation. So let's plug that in. So we say take out this x and we're going to plug in the negative 4y plus 26 in that x's place, and then you have a minus 5y equals negative 10. All you have to do is, what we've done is we've simplified this down to one equation and only one value we don't know. So you can plug in, or you can just simplify. This will give you a negative 9y plus 26 equals negative 10. And we solve this two-step equation. So let's subtract 26. And you get negative 9y equals negative 36. Y is going to be equal to 4. So that's half your answer. Now what I've done is I've circled a couple of things here. The reason I circle what I substitute is number one, so I know what I'm plugging in, but also because once you get your first variable, you can take this y value and you can plug it into wherever you circled originally. Because if you take this 4 and plug it in for y, you're going to get the answer for x. So we're going to say x equals a negative 4 times 4 plus 26, which will give us a negative 16 plus 26, which will give us a 10. So here's your x, here's your y. Your final solution ends up being 10, comma 4. And there you get your solution of a little bit more difficult substitution problem.